from the group 2. So this is about substitution. We've just seen it. Yeah? This is something that is purely mechanical, pure syntactical. You don't have to think. Yeah, just turn off your brain and just copy symbols from the left to the right. Yeah, that's what it is. So I'm gonna do one, and then we'll do the others. Okay. Let me stop share. Okay. So can you see the screen? Oh, I mean the whiteboard. Right. Yeah. So the thing is, I don't know the. Okay. So I assume you have the exercises with you in our, laptop or printed or on a phone or your whatever. And the very first one is this one. So I'll do this one and then we'll do the other very quickly. Yeah? So this is what. So x minus lower equal than 9, and then you're going to visualize. Okay. So the way you read it is whenever you find x in here, you write a 4. Okay, that's the idea. So the result of this is the expression, the formula, where all occurrences of x are replaced by 4. Okay. So you basically start. Sorry? Yeah. Very good point. Okay, so yeah. We see, someone can check the chat for me, then it will be very helpful. Yeah? So basically what you do, you start copying symbols, yeah? So you have this symbol, you copy this symbol. Then x comes, but x is to be replaced by 4, right? So rather than x, you write 4. Right? Then lower equal, you copy, and 9 you copy, and the close friend you copy. This is what you get. Okay? It could be easier than this. Yeah, can you do the other ones? Quickly.
So if it's y, then it means that we don't substitute nothing, right? X plus or equals to y.
You're talking about b?
Yes.
Yeah.
Because x and then 1. Sorry, 4 and 1. So we don't have substitute nothing, right?
Okay. So basically, if this variable does not occur in this expression, then it's just cool. Yeah. The input is equal to the output. Yeah.
Yeah.
Up to like F or something.
Yeah.
I think I know the right one.
Oh, yeah.
I've written it till F. So, how does this sound to you? Yeah? This is what you have? Everybody? Yeah? See. Okay. This is pretty much obvious. The only so here, for example, here, because y doesn't occur in this expression, then this is just the opposite. Here again, there's no x here, it's just no. But here you get x here. And here it doesn't occur again, so you get the result, which is here. And here you replace x replace here. You get the 0. Otherwise, everything is just like before. Yep. Makes sense. Does it not? Sounds okay? Estão a ouvir mal?
Since there's no x in the expression,
Estão a ouvir mal. O que é que eu vou fazer? Posso berrar? Não ouvir mal. Ok. Tanto o F do G vai o okay. O último é o erro da introdução. Yeah, that's what I thought that you could be Okay, ready? We all have something in this. Yeah. What about you guys? Is this what they have? I think the only one that really deserves some attention is It's the last one. Otherwise, this is pretty much trivial. But this one, I think about. Yeah, just in case. In this case, it is not absolutely necessary. Yeah. But suppose that you have here plus and times there, then you would certainly will have to have the parentheses. So just in case, just add the parentheses. So this is done in 2 steps. Yeah. So you start from this. So the very first step replaces all operations of y, but by z plus 1. So there's an intermediate step here where you have x greater than z plus 1 and z plus 1 lower equal than no, and y no, yeah, and, that's it, yeah, right. So this is the intermediate step, and now here you have to reply then the second substitution. The substitution is z times z by z. Okay, so it means that you'll be replacing here and there and there, which gives you this and this and this. Yeah, straight down. That's it. Okay. Yeah, are we happy? Are you happy, guys? Is there anything in the chat? Tudo ao capas. Pedimos que não falte costas. Okay. I'll do my best. Okay. So now we go into some of these exercises. My plan is not to do them all, but instead to do those that are all on the website. So my plan is to do, let me see. My plan is to do A, D, C. Right, that makes very much sense, right? So A, C, D, F, G, H. This is probably with 2 emissions, yeah. Okay, but I think we can go. I think we can go quickly on the first. So I'll do the first one, and then I'll do the others. So this is just an example of what we've seen before. Oh, Jesus Christ! Why? I'm not thinking. I swear. Okay. Okay, so. So how do we do this? So really, I think this is the most difficult part to get through in the beginning, is that you have to reason backwards, yeah? You go from the end of the program to the beginning. You're not used to do this, right? You open a book, you read it from left to right, okay? So now I have to do a little bit like, you know, Japanese. You have to read from the right to the left, yeah? And so this takes time to get used, yeah, because it's a bit non-intuitive. But remember, this is purely syntactical, yeah, mechanically. We don't have to think, yeah. You can turn your brain off and just work. Okay, the machine can do this. Can you imagine? These stupid machines can do this, so why shouldn't we be able to do this? So basically, what we have is we have x plus 1 of x times plus 1. And we'll concentrate on the first condition, 6 greater, x greater than 6, right? Right? Forget about the precondition, okay? So now what we do is we do backward calculation, okay? Okay, from the end to the beginning. So what we're going to do is we're going to do these substitutions that we've just seen, yeah? So we're going to write here something. which is what? Exactly what we find here, okay? Symbol by symbol, but in the places where you find x, you write x plus 1. Yeah? Because x is on the left and x plus 1 is on the right. So this is this idea of transposing the property of being greater than 6 from x to x plus 1. Okay? That's the idea. So what we have here is we go from left. So it copy x, but wait a minute, x is x plus 1. Okay? So write x plus 1. And then write greater than, okay, just copy. And then you write 6, you just copy. Okay? This is what it is. So because it proceeded this way, this is automatically an instance of the sign rule. Okay? Yeah.
Sorry, wasn't it supposed to be 5 instead of 6?
I don't know.
Because you only need to substitute the x, right? Like x plus 1.
But you know, let me put my glasses. No, it's x greater than 6 in the conclusion, no?
Oh, okay. I thought that.
Okay, here.
Yeah, I thought that we needed to. That is what we're writing right now, the precondition, and the precondition is x greater than 5.
Yeah, I'll do that, you know, in a second.
Oh, okay. So,
Can just do it.
yeah.
So the major step is forget the precondition and build it. So by working this way, okay, you know already that this is an instance of the sign. By construction, you don't have to prove anything else. Okay, but unfortunately, the precondition is not x plus 1 greater than 6. The precondition is x greater than 5. Okay, so now here what you have to strengthen. What do you know? You know that x is greater than 5. What do you have to know? That x plus 1 is greater than 6. Can you deduce this? Can you by knowing that x is greater than 5, can you conclude that x plus 1 is greater than 6? Obviously yes, by simple properties of arithmetic, right? So you strengthen your precondition because you have the precondition that you really have is x greater than 5. Right? This is the original precondition. But the actual precondition is this one, x plus 1. So what you have to do is to strengthen. To make it stronger. Okay? So this one is stronger than that. In fact, they're equivalent, right? But anyway. So once you do this, then you can use the left strengthening because that's what it is. The left is strengthened to this one. And now how to conclude? You conclude what you want. So this one is here. And everything else remains the same. Okay. So the assignments, this is the standard pattern for assignments. Okay, but you have to work backwards. So the only place where you have to turn your brain back on is to prove this. So in exams, well, we're not having exams, but in the assignment, you will have to write. You have to justify. Maybe we can write like this. And then I have to justify x greater than 5 implies x plus 1 greater than 5. That's 6 because x plus 1 greater than 6 is the same thing as x greater than 6 minus 1, which is the same thing of x greater than 5. Something like this. Yeah? You have to justify this. And this is basic simple arithmetic that you have to do. But you have to write this. Yeah? You have to, yeah. This is the only place where you have to turn your brain back on. Yeah? And go back into your algebra classes of undergrad, or secondary school or whatever. Yeah. So this is something that I have to do. if you don't justify this, then I cannot give you the full mark for the exercise. Yeah. Yes, go ahead.
What if like there's like I'm sure there's going to be like some examples where like the variables or the variables that are on the precondition are completely different than the ones that are on the post condition. In that case, I'm sure that this will come up, but in that case, do we still have to do like
Yeah, I think so. This is a JavaScript. It works everywhere, with every instance. So whether they exist, whether they don't exist, if you can prove this,
because now it makes sense, like what it is, but if there are like completely different like variables, it might not make much sense. I don't know if I'm being.
the thing is, if sometimes you cannot prove this, therefore you cannot prove this. It may happen, right?
Okay, yeah. Okay, yeah.
It's not that everything is going to be.
Yeah.
Oh, I already raised this. So so I want to do one of these. So which are the examples that I had? I think I'll skip C. D, F. Okay, so we skip to D. Okay, this one. ID. So this is my plan. So we jump to D. Yeah. Can you do D? Oh, we've done this, have we not? We've done this in the other one. Huh? Yeah. Okay. Okay, so this one is on the slides. So we go to E. Oh no, we don't do E, no, we do F. We do this one. This is too simple, but anyway, let's do this. F. Depois da FPI, depois da FPI, sim.
Daí alta no computador. Não recebe no computador.
O passa a 3. Tem que fazer. Eu estou a tentar perceber como é que normalmente é. E falta fazer com o motor. Não, não, este aqui. Este aqui é o 3. Vais fazer isto sem estar aqui no formulário. Ok, então primeiro isto, depois e começa a fazer esta aqui, não, não se põe neste caso. Este truque é como se significa bocado. Seja meu que algumas não, algumas que eu acreditar bem. Pois não, isso é que eu fico pensando. Aqui depois eu vou provar, depois a distância do certo. Tem sendo a implicação isso. E aqui, ok, tenta perguntar isso a ver. Mas está mal. Ok, so is it right here? Pessoal, é assim que vocês têm? Está fixe, tá? Portanto, temos aqui backward propagation. E temos aqui assim, sorry. As we justify in Portuguese or in English or Japanese if you want. Why true implies 3 greater than 0? Okay, so this might look like pretty much obvious, but you still have to write 3 equals to 0, 3 greater than 0 is true, and true implies 2, something like that. Yeah, don't forget. Okay, G. Oh, G is, what time is this? Okay, G is okay. So all of these are exactly of this form, right? It's always like this. All these examples, G and F, G and H and all this, yeah? The shape, this is a tree, yeah? It's a very small tree. You'll see much larger trees. It's already a tree. Very right.
Essa porque estavam coisa da base da comunicação política. Certo.
And what is equal to Queria deixar os discos azuis e o sangue ao yes. Mas não estou para falar aqui do mundo. Okay, so wait. You also have to write this here. You have to write. Oops, no, there's something wrong here. So this bit goes here. Okay. And so this is the justification. Okay. And here in the conclusion goes the goal. And the goal is x greater than 5 and x greater than 5. X colon equals to. Okay. So it's always like this. Implication here, and this is the sign. like this as a tree. Yeah. So really, so if you look at this may look a little strange in the end because it says that if this problem terminates, then in the end is x of x is equal to 24. But you know that in the end x is equal to 3, right? But the thing is, you started from a precondition which is false. So when you start from false, everything can happen. Yeah, because false implies everything. False implies false. False implies true. False implies everything. So if you start from false, anything can happen. So the justification here is the justification is as you know, false implies. This one is also okay. But that's it. So the thing is, these triple holds. This is true. Yeah, this is true because it says if you start from a if you start from this here, so this is true. This holds. If you start from a state satisfying this, so now can you figure out what a state is that satisfies this precondition? A state where variable x is both greater than 5 and greater and lower than -5. No? Can you build a state? Can you tell me what is a possible value of x? No, there is no possible value for x. Okay. So because there is no possible value for x, this is false, and because this is false, everything can happen. Yeah. Here you can say that x is equal to 24. Okay. You can even say that you know, Sporting will be champions. Well, no, it's true. Yeah. Got it? So, and then the next one is we're not going to do the next one. The next one is exactly the same. So this is this idea of hell breaks free in the sense that anything can happen. So if you start from false, anything can happen. You can prove anything. Yeah, it's lovely because the thing is, but no state satisfies false. Therefore, it's okay. So you have to be very careful in order not to start from a precondition which is false. Otherwise, you can prove everything. Okay, a different one. So how much time do we have? Half an hour, yeah? Different one. Let's go to F. No, I. So undefined. So how do we do this? Now we have a semicolon, right? So if you have a semicolon, you have to use the sequence rule. So the sequence rule says if you start from phi and you want to psi, then there must be an intermediate formula here. Okay. This is the and you have to find it out to find out which one it is. Okay. And again, you go from the beginning to the you go from the end to the beginning. Yeah. So this is the set rule. So in our case, we will have a set rule here because we have a semicolon. So we have skip, semicolon, skip. Okay. So this is S1, this is S2. So here we have skip. And here we also have skip. Yeah. So here you can write the conclusion, the post condition, which is that x is equal to 5. And here you want to write the x equal to 5 again. Yeah? So it means that x is equal to 5. And here also know that x is equal to 5. So now all that remains is to guess this. Yeah? This is 5, this is 5. So what can you write here? Now, you have to remember that the rule for skip. So skip is the expression that does nothing. It doesn't change anything. So whatever goes in goes out, basically. Or whatever goes out, it means that it went in before. So the rule for skip is whatever goes in goes out. So basically, we have to copy this from here to there, from here to there. Yeah? From right to left, yeah. In general, in this case, doesn't matter. But if you have assignments like the next one, you have to go. Usually, you go from the end to from right to left. Always from the end to the beginning. You have to reason backwards. But in this case, no assignments is okay. So basically, here what we have here is. So this is the intermediate formula. You have to figure out which form it is. Yep. So from this, I think you can adapt this quickly for G. Okay. So the difference with G is now that one of the skips becomes an assignment. Yeah. Can you do that? Não, vocês só precisam justificar as implicações. Yeah? You only have to justify the implications. There are no implications here, there's no justification needed, right?
But next time I will.
There is something that is considered in short play. It's normal. And
No. No.
So we have to go from like one to the next, so exactly. But next we have to yeah, okay, yeah. Yeah, of course.
Okay.
And then that's it. And that's okay. But
yes, yes. Essa não é lá para mim. Pode estudar mais um passo. So, eu escrevi uma coisa nesta parte aqui, que supostamente começa mais zero. Eu não faço uma questão aqui. Depois aí vai poder ver. Mas infelizmente eu também quero chegar para ver.
Só que não pegar aqui no
Depois dentro do 4%.
Isso aqui são duas. Ou é só o. Deixa eu ver. É simplesmente uma coisa. Ok. Não está nem primeiro, estás a ver? Ok. Faz implementação que aparece. Ok. O output do SEO é o input do SEO. Com a atualização do SEO é a trabalhação do SEO. Você tem a mesma. Infelizmente, acho que duas vezes isso. Era toda aí uma decisão mais. So for example, começar não mais fazer isso os que tiveram do blog muito para Okay, so let's see. So is this fine or not? So the question is, how do you start? How do you build this? So before we start, let's see if this is okay. Okay. So there's the. So one is that how do you approach the problem and to start to solve. The other one, which is easier, is to look at the result and see if it makes sense. Yeah. So let's look first at the result and see if it makes sense. So what we have to do, starting from this, x is equal to 0. You propagate, you get three greater than 0. Okay. So this is again. Jesus Christ. So this is okay. This is okay. And also this one, because this formula is exactly like that one. This is okay. Okay. So this is an instance of scheme. Okay. So this is also okay. And then what? And then these two formulas are the same, yeah? Which is this one, this will be this formula. Okay? So this is a good example of okay. So this is also okay. Yeah. And now this, well, this should be a little bit more beyond those, yeah? Not that this, but anyway. Other than that, what you have? You have these are equal. The statements are where were we? Yeah. Okay. Okay. Sorry. So you start from the bottom, yeah. So, but then how did you come to this conclusion here that you needed it here 3 greater than 0?
I tried the x first,
Yeah.
from the right.
Yeah.
I tried it for a 3, and then I use the skip, and it goes to the 7 and says 3 is greater than 0.
I don't know. I think you'll have to do a few exercises until you figure out how to go from this. But the problem is you end up writing. So I think so you actually build this upwards. But if you build it upwards, you have to anticipate that you need this implication here, which might not be so easy. So if you build in this direction, maybe it's easy because really in these kind of examples, you go from the So you read the program backwards, yeah, from the end to the beginning. So I would start here, maybe here, because this is the post condition, right? So you do this because this is the last instruction. And then you go back to the other one. Okay, this is the second last instruction. In this case, it's the first. But, okay. So you do the back propagation. You do the back propagation. And you get this. Then from here you copy.
Professor,
Yeah. And then because this is an assignment, you copy again. Okay? Because it's a skip, because you copy here.
professor,
And here you copy. And then you conclude. But it is third. Then you conclude by using this one. But unfortunately, what you want to prove is x greater than 5. And what you have is 3 greater than 0. Okay? Then this is time for left strengthening. Okay? So you separately, you prove this, you show this, and then you have to write it. Right? Now, why is it the case that if x is greater than 0, then 3 is greater than 0? So if x is greater than 5, then 3 is greater than 0. Why is this so?
professor,
So why is this true? So and anything implies true, right? Anything. Yeah, even false implies true. So the last example of the day is you do is this.
professor,
Okay? Não tá me. Sim, não?
professor,
Ligou o som. Não, vocês não me ouvem? Hello? Hã? Não usei o quê? Não usei o quê?
Não.
Achas? O professor não nos ouve. Não ouço. Agora já ouço. Ok, eu tinha o som baixinho. Obrigado, eu tinha o som muito baixinho. Agora já está alto.
O professor, tá, a
Está tudo bem
imagem
desse lado?
a imagem ali no quadro não tá dando para ver nada mesmo. Tá tipo 240p. Tá mesmo baixa a resolução, não sei se é a rede ou o que é. Não dá mesmo para ver. Olha lá, tem hora que fica bom, só que aí de repente se o professor mexe, por exemplo, e desce a qualidade de uma hora para outra. Eu não tô a ver por que que... Antes de cair estava bom, e a hora que caiu ficou ruim, ficou desse jeito.
Podemos mudar isto tudo de novo. Eu acho que o que aconteceu agora é exatamente o problema da rede. Aqui apareceu a Poor Network Connection. Okay? E eu imagino quando o sinal seja fraco, ele baixa para 240p, ou até 120p se calhar. Okay? Mas é capaz de ser isso, deixa lá ver se eu tenho muita rede ou não. Aqui não tenho que dizer aqui. Não sei, mas acho que está melhor? Eu posso aproximar um bocadinho mais, mas...
Pois é, que aí nesse caso,
não?
é que quando fica paradinho, parece que ele entende que a imagem está estática e consegue melhorar a resolução. Aí, na hora que, aí, por exemplo, agora ficou bom. Aí, de repente, o professor mexe, ele desce a qualidade de novo. E não dá para ver mais nada.
Pois, eu não sei muito bem o que fazer, até porque me disseram que aqui no C8 tínhamos os 9 access points e que estava tudo muito bom.
Ah, mas nesse caso, então, se o professor não importar, é depois que ele terminar de escrever, ele deixar paradinho um tempo só para a imagem estabilizar, que aí a gente...
Está bem, vou fazer isso.
É que
9 minutos, 9 minutos para fazer o exercício L, sim?
Obrigado.
Dica, a estrutura da árvore vai ser muito parecida com esta, certo? Se é que não é igual.